All right, so let's talk about row operations. And so here I've actually gone to the notes, the online notes that I've created. And I wanted to point out one thing about that as we go. Notice that there are these different code blocks we have here. And you see here, if you hover over the upper right-hand corner, it says copy. And if I click on that and then I go to MATLAB, I can paste, edit paste, and it will actually bring the code from the code block here on the online course notes, and I can put it here in MATLAB. Okay, so that was one of the reasons I did the online course notes, so that the examples that are on the online course notes, you can just copy them quickly and put them into MATLAB and work on them. Okay. So just one quick tip about how to use MATLAB in the online course notes. And let's talk about row reducing matrices. So hopefully you've already watched the video that went through the PowerPoint and showed the strategy that we're going to use, as well as talking about the 3-row operations. So we do have 3-row operations, which are cool. They're called elementary row operations. And none of the 3 actually change the solution set to the set of linear equations. Okay, so I can do any of these things. It won't change the solution. So I can use these to simplify the matrix. Okay, so the first thing we're going to do, though, is we need to talk about how do I call a row in MATLAB. Okay, and first things first, we're going to need an actual matrix. So I created this matrix M. And so let's just get that all initialized. And I'm going to run that. Okay. And now, how do I refer to a row? Well, first let's talk about a specific entry, okay? So if I want to reference the 3rd row, 2nd column, right? So that's this value here, the -3. Sorry that I've written all over that and you can't see it now. What do? Well, I use parentheses. I do 3, 2. So row, comma, column. I give it which row I want first, comma, tell it which column. Okay, so let me get rid of all that ink. And you can see that the answer is, in fact, the -3, right? Well, so now it turns out that we have this colon operator. So it'll get every possible column if I put the colon in there, the colon, and it gives me the whole row. Okay, so the first thing I specify is the row, and then I put a comma in, and then a colon, and it gives me the whole row. All right, well that's fairly nice, because now I have a way to reference the whole row, the entire row. And then I can actually do my row operations by using this nomenclature, right? So swapping 2 rows, how does that work? Well, it's really interesting. In the row part, I just swap them. So I'm calling the matrix and I'm setting it equal to itself, but what's different? I put the square brackets in where the row code goes, and I put in square brackets and then the name of the 2 rows that I want to swap. And again, I do them in the opposite order. So this will assign row 3 to row 1 and row 1 to row 3. All right, but it's real easy. If I want to swap 2 rows, just put in square brackets and again, put them in one order in the first matrix equals, and then put them in the opposite order, and that will swap the 2 rows. Easy peasy. So that's a fairly straightforward one once you know how to do it. Okay, and of course you can run it and you can see that it has swapped, right? Why? Well, if you'll remember, the 2 and the 4 are the first row, and the 6 and the -3 are the third row. And when we scroll down to after the row swapping, right, the 6 and the 3 are now first instead of third, and the 2 and the 4 are now the third row rather than the first. So this has in fact done it. Also notice that we've changed M. All right, so if we just say, hey, what is M? Notice that it's the row swapped version. Okay, so once I do this row operation, it changes the matrix permanently, which is not a problem because we're simplifying the matrix, but that's going to come up. So keep that in mind that these row operations will actually change the value of the matrix. Okay, so now we have this new M. And what if we want to multiply row 3 by a scalar? Okay, and up here it says we're going to do it by -4. Okay. All right, well, what do? I just set row 3 equal to itself times a scalar. And again, the scalar can go before or after, but with a minus sign, it was easier to put it before. And then I can run this, and you can see that it does, in fact, take the row 2, 4, it multiplies it by -4 and gives me a -8 and a -16. The rest of the matrix remains unchanged. Okay, so this is how we multiply by a scalar. Again, we just call the matrix row that we want. That's the third row of M is equal to the third row of M times the scalar. Okay? So that's fairly easy to do. And then the last one is a little bit harder. Replace any row with the sum of that row and a scalar multiple of another row. Okay, so let's look at how we get that done. So we say, hey, I want the new row 3 to be equal to the old row 3 plus a scalar multiple times row 1. Okay, new third row equal to the old third row plus a scalar times row 1. So I can do this with any rows. Why did I do 4/3? Well, I did 4/3 because if I want to go up here, let me get rid of the ink and go up, right? I'm doing this because what if 6 was a pivot and I wanted to get a 0 in the third row in the pivot column? What would I need to do? Well, think about it. If I divide by 3, 6 divided by 3 is 2, then multiply by 4, that's 8. Then I'd be adding 8 plus -8, and I'd get a 0. So I chose the row operation that would help me get a 0 in the third row beneath the pivot if the pivot were 6. Okay, so when you run it, it does in fact work. We do in fact get our 0. And so those are the 3 row operations that we're going to use. Okay. Lovely. Now let's get some practice. Okay, so what if we need to reduce the matrix A to REF form? Now remember, REF form, I get zeros below the pivots, but the pivots don't have to be 1 necessarily. And I don't have to get zeros above the pivots. Those last 2 steps to get to RREF, we do not have to do. We just have to get matrix A into REF form. Okay, so let's do this. I'm going to come down here below the matrix, and I'm going to get some code. Why? The first thing I'm going to do is A equals capital A. Little a equals capital A. Why am I doing that? Well, I'm doing that because, again, as I go through and do these row operations, it's going to change the matrix. But if I start with a different matrix name, lowercase a rather than uppercase A will be the original matrix. And lowercase a will be the thing I can work with. And that's really cool because I can save all my steps. And if I make a mistake, I can go to the place in the little a matrices where I made the mistake and fix it. And as long as I still have the matrix that I started with ready to go, then my steps can be applied to it. All right, so this is the trick I use. I start with little a, and by the way, lowercase letters are easier to type. We usually use uppercase letters. If we're writing on the whiteboard in class, we'll use an uppercase letter for matrices, and lowercase letters will be other variables, but it's easier to type a lowercase letter. So I'm going to use lowercase a while I am working. Okay, so the first thing we want is we want a pivot in the top left corner, and I have a 9. 9's not the pivot that I want, but notice what's right below it, right? Oh, so row 2 has a 1 in its first position. So that gives me an idea of what my first row operation should be. So what do I want to do? I want to swap rows 1 and 2. So comma colon equals a parentheses square braces. Then I'm going to do 2, 1. Remember, do them in the opposite order. And then boom. So now what have I done? Okay. And by the way, putting this semicolon after, it just closes the row, but allows me to put multiple lines of code in the same code block. So it was just saving some space here. Oh, and by the way, I suppose that I have forgotten to mention that right over here, and you can't see it on my screen, but just off the screen to the right here, I can switch the output views. And so some of the output views go ahead and make the output available on the right, which I don't like it that way. I don't like seeing it that way. So I prefer this, where I type a command and then it shows me the result right below it. So I like this inline. And so use what you like, but yes, those things are over there, just letting you know. Okay, so we've got a 1, so we've got a pivot in the top left. All right, and let me get a code block. There we go. Okay, so now we want zeros below that pivot. Okay, well, I can take -9 times the first row and add it to the second, and that'll get me a 0 in the second row first column, right? So I want to take A2, so row 2 is equal to row 2 minus 9 times row 1. Okay, row 2 equals row 2 minus 9 times row 1. Boom. And hey, check that out. It worked. Okay, and I'm going to get another code block. What's my next step? Well, I want to get a 0 in the third row first column, right? And by the way, I can see that it's really, really close. So when I'm working in the same column, I'm doing almost the same thing, except now I'm working on row 3. So I switch row 2 to row 3, and I want row 3 to equal, oh, not minus 9. I want it to be equal to minus 8 times row 1. Boom. Okay, so now I have the pivot in the first row, first column. I have zeros below it. And now I get to wash, rinse, repeat, and work on this 2 by 2 in the bottom right-hand corner and see what I can do with it. All right. Well, let's do it. Code block. What do I need to do? The first thing I'm going to do is I'm going to switch rows 2 and 3. Why? Well, you'll see in just a second, but it turns out that row theory is a little simpler. So let me just swap them real quick. So I wrote 2, 3 first. I'll do 3, 2s in the second one here. So yes, just a real quick row swap. Boom. And a code block here. And now I want to multiply through this row. See this second row? It turns out that 72 and 40 are both divisible by 8. Okay, they're both divisible by 8. So basically I want to multiply through by 1/8 or divide by 8, however you'd like to think of it. And I want to do that to row 2. So I'm going to specify row 2 is equal to row 2 divided by, but now I've got a problem, right, with this -8. So I'm putting parentheses in to make sure that it knows divide by -8, not divide, subtract by -8. I don't know what it's going to do, but that will give me the right thing. And oh, notice, look what happened, right? So now row 2 is nice integers. And I got rid of the negative signs too. You don't have to. You can work with negatives. A -9 would be fine. But it just makes it easier, for me at least, to get rid of the negatives as well. Okay, and we're almost done, right? REF, all I have to do is get a 0 below this 9. Why? Well, because then my pivots will be 1 and 9, and then whatever this turns into, right? And I'll have my REF form that I'm looking for. But how am I going to take that 79 and turn it to a 0? Holy smokes. All right, so I need a row A3 equal to the third row of A. Okay. Plus what? Well, I think 79 ninths would do it, right? If I have 79 ninths, 9 is in the denominator, which will cancel with the 9 in the numerator, and then the 79 is left in the numerator over 1. So I think that's what I need. So I think I need to do plus, plus 79 ninths times, and which row is this? We're going to do row 2. So row 3 equals row 3 plus 79 ninths times row 2. Let me see if I got that right. And notice that the order of operations does work as it should, right? It does the multiplications and divisions in order from left to right. So it does the 79 divided by 9 before it multiplies this scalar times row 2, so we get exactly what we need. Yeah, and if you're unsure about the order of operations, you can always throw in some parentheses like I did above, just to make sure you get everything grouped up right. And we're done. Okay, this is, in fact, a matrix in REF form. Okay. Well, let's try another practice problem. Well, let me do one more thing. So I can come down here, and this is the solution. Okay, so I did work this out earlier just to make sure everything does work out. And so again, I can separate the rows by semicolons, right? So I can put a semicolon in, and it suppresses the output until the final go. But this is a way that we can keep the solution code in our notebook and make sure that we get the right thing. You know, we can check to make sure that it's correct. And let's say, oh, dang, you find out that you made a mistake here. Okay, well then I can go back and I can fix this code and rerun the whole thing and see if I get the right answer. Okay, so this is a way to keep all of your work together in a nice, easy format where you can save your solution path. And then, because you have a saved copy of every single step that you took, you can go back easily and find where the error is and fix just one thing. You don't have to redo the whole problem from start to finish. We can just redo the problem and find which step it is that's a mistake and fix that. Okay, so there are a couple more examples here, so let's take them on. Reduce matrix B to REF form and solve. By the way, I'm going to admit right here that you can actually do RREF and you can see what it is. Okay, that is RREF form, but that's not what we're asked to do. We want to row reduce this matrix, okay? But we know where we're going, and we can always check our work. Okay, so the first thing I want to do is I'm going to do B equals capital B, right? And I'm going to put a semicolon after that to suppress the output. All right. And then what I want to do, well, the first thing I would like to do is and by the way, there is some leeway in how you do it. Not everybody has to do the exact same steps in the exact same order. Some steps you have to do in an order, but what I'm doing here is I'm just multiplying the first row by -1. Why? Well, because I like having positive ones in the pivot positions. And we have to go to our REF anyway, where we need ones in the pivot position. So let me just go ahead and start with a 1 in the top row. Okay, now I'm going to get zeros below. So there we are, zeros below. What do I need to do? I just need to add rows 1 and 2, and then I need to add rows 1 and 3. So row 2 is going to be a copy of itself plus row 1, plus row 1, boom. And notice that we did get the 0 that we need. I'm going to copy paste this. Let's see, where's the copy? Well, that was that was harder than I thought. Let me just quickly get this running again. I'm sorry. I'm just making sure that everything's up to date and correct because I made that mistake. All right, but I want to copy this, so I'm going to hit Control C. So edit copy, come down here, change to a code block, and I'm pasting it in. But now I want to do the same thing I did for row 2, but I want to do it to row 3. So I'm changing the row 2s to row 3. Now this is saying, hey, replace row 3 with the sum of rows 1 and 3. Boom. Notice it does that. So now I have a pivot of 1 in the top left corner of the matrix, and I have zeros below it. Okay, so now I need a pivot in the second row, which, as I believe you can see, I have a pivot there, and it's a -1. So all I'm going to do is I'm just going to multiply through row 2 by -1. So B2 equals -B2. Okay, so second row of B equals -1 times the second row of B, which just flips all the signs. Okay, so now I have a +1 in that position, and so how can I get rid of the 4 that's below it? So I'm trying to, oops, sorry. I'm trying to get rid of that 4. Okay, and to do so, I'm going to take row 3. Row 3 is going to equal to itself, row 3, minus 4 times row 2. All right, so -4 times 1 plus +4 will be a 0. So this is what I need to do to get a 0 below the second pivot there. Boom, and voila. Right, so the -4 times, I'm sorry, the -4 times the 1 plus the 4 gives me the 0 that I need. And then these are just the same operations done to the corresponding entries. So that worked. Am I done? No, I need a +1 here to be in RREF form. That's not too bad because I can both numbers are divisible by 4. Both numbers in the third row are divisible by 4. So I can just say, hey, I want row 3 to be equal to row 3 divided by 4. And you know what? I'm going to divide by -4. And so you'll notice that that's going to get me a +1 here. I'm going for RREF, and there, cha-ching. Now, by the way, this is a fairly easy thing to solve, and I'll tell you that a lot of times we just go to REF, and we do what's called back substituting, because in this form I can say, hey, x sub 3 is equal to 4. And then I know that x sub 2 plus 2x sub 3 is equal to 3. So if I know what x sub 3 is equal to, I can plug that in, and I can solve for x sub 2. Well, then, if I know what x sub 2 and x sub 3 are equal to, I can plug them in, and I can solve for x sub 1. So it's called back substitution. So a lot of times, the fastest way to solve a matrix, if we're trying to find the solution set of the matrix, a lot of times the best way to solve it is to go to REF form and back substitute. Okay, so if we're talking about just quickness and efficiency, you'll see that a lot. That is a good way to go. But that's not what our directions told us to do. Our directions told us to go to RREF form. Okay, so with RREF form, I need to get zeros above the pivots. Well, the first one I'm looking at is right here. So I'm going to have to replace row 1 with the sum of itself in row 2. Notice I have a 0 below the pivot, so that won't change the pivot or anything, but it will get me where I'm going. So I'm going to replace row 1. So I'm going to take the first row of B equals the first row of B plus the second row of B. Boom. It didn't like it because this is a semicolon. I don't know if you can see that, but there I got it right. And I did get the 0 above the pivot like I wanted. Yay. Okay, now I need to get zeros above the last pivot. Okay, well, the first thing that I need to do is fairly easy because I can just add the first row and the third row. So I can replace row 1 with the sum of itself plus row 3. Oh wait, minus row 3. I want a negative 1 times row 3. Okay, and that does get me the 0. And then final step is to say, hey, so now I want B2 equal to, so I want the second row of B equal to the second row of B minus 2 times the third row of B. Okay, so what's that going to do? Well, it's going to add them together, but notice I have zeros in the first two places, so it doesn't mess up anything to the left of where I want to work. It's just going to get me the 0 there that I want, which is why I chose it. That's why I chose to do it that way. Boom. Oh, yay. Now we have RREF form, right? We have positive 1s in every pivot position. Okay, positive 1s in every pivot position, 0s below all the pivots, 0s above all the pivots. So yeah, there we go. And why do we like this? Well, this is kind of cool. And I am going to, let's see, I'll type it out and show you, right? The first thing I know is that, oh wait, I want text, don't I? The first thing I know is that x sub 3 equals 4. Why do I know that? Well, it's right here. 1 x sub 3 is equal to 4. Remember, the augmented matrix has a line there where the equal signs go. So this basically just says, hey, x sub 3 equals 4. All right. And then I go right up, x sub 2 equals negative 5. And x sub 1 equals negative 3. All right, very cool. So we just read off the solutions. When I get to RREF form, there are my solutions, x sub 1, x sub 2, x sub 3. Now again, I tend to go backwards just because the easiest one to read, if I have several of them, is the last one. X sub 3 equals 4. Of course, you could have gone in reverse order, but the solution set stays the same. We know what x1, x2, and x3 have to be equal to. Okay, so again, is this always the most efficient way? No, but it's a good way. And when I'm interested in just raw speed, remember, I can just go to REF form and then back substitute. So there are two different ways there to solve a system of equations. And in example 3, that's what they tell us to do. They say row reduce and solve matrix C. Okay, so we have to use row reduction to solve, but we get our choice of what to do. And again, this is big and ugly, but if you want, you can just delete everything and put semicolons after every row. And this is what I did to get the solution for A. And you know, we kind of run out of room, so I'm going to start getting another line of code here, semicolon, and then delete, and then semicolon, and then delete, and then semicolon and delete. Man, how many of these are there? Oh, and that's good. So let me do this. Okay, and this is how I got the solution. So look, if I have B here, and then I do all of these row operations in order, I get to our REF form, and then this is the solution. So this is a way to keep track of our answers in a very compact form, and we can check our answer at the end to make sure that we have it right. Okay. So now we get to choose what we want to do when. So I'm going to do the same thing that I've done in all of the other instances. Well, first of all, maybe I should make it code. All right. So little c equals capital C. Okay. And notice that we don't have an easy way to get a number 1 pivot without introducing some fractions. So all I'm going to do is I'm going to swap rows 2 and 3. So I wrote 2, 3 first. I'll do 2, 3 second so that they're swapped. And you can see, okay, so wait, I didn't want to, oh, dang it. I didn't want to swap rows 2 and 3. I wanted to swap rows 1 and 3. And again, this is a nice time. Let's see, 3 and then 1. Why? Well, I don't want this negative 2 up there. I want a positive 2, right? So I want to take row 1 and put it up here. And then I'll have a positive 2 to work with as my pivot. I don't need a 1 because I don't necessarily have to go that far, but that's what I'm trying to do. And notice that if I have the little c equals capital C and then I change the lowercase c matrix, I made that mistake. But fortunately, I can just go back in, change it the way I want it, and boom. Now I do have the correct matrix. Okay. And then what? Okay. So I want to add rows 1 and 2, and the sum will go into row 2. So I want the second row to be equal, the new second row to be equal to the old second row plus row 1. Boom. And that gets me a 0 below the 2, the first pivot. Okay. And then how am I going to take the 2 and get rid of that 3? Well, think about it. I need a 3/2 times the 2. Why? Because the 2 will be in the denominator, which will cancel the 2 in the numerator and leave me with a 3/1. But that may need to be negative. So let me get that right. So I need the new third row. Sorry, and that's a colon again, not a semicolon. There we go. So the new third row to be equal to the old third row minus 3/2 times the first row. Okay, now notice what it did. It had to introduce some fractions, and when it has to introduce even one fraction, it starts representing all of the matrix entries as as these tedious decimals with lots more decimal place accuracy than we need. But that is how it goes. Okay, so that's how it goes. Let's notice this, right, that we have a 0 here. So if I can do some row swapping, I can avoid having to do too much work. Okay, so let me row swap. Wait, code block. So let me row swap. What do I want to row swap? I think rows 2 and 3 will work. And then I'm going to do, in square braces, I'm going to do 3 and then 2. Okay, so now it's not lovely, but I do have a pivot now, minus a half. Okay, if I wanted to, I could multiply through by 2. I'm not particularly interested in that right this second. Well, maybe I'll do it. I'll do it. Let's try that. So down here, then I want old row 2 to be equal to, excuse me, the new row 2 to be equal to the old row 2 times 2. And that's got a negative one there, so I do have the option to put in a minus 2 instead of a positive 2. Again, I'll use parentheses so it doesn't freak out. Oh, and I noticed that I'd already changed the matrix and then I changed it again. So I can't just hit it again. I have to go back and rerun this all. So this is a nice run to end, right? So I get my stuff in here and I use run to end and it reevaluates everything for me all the way down. And notice it's actually, since we got rid of some of the fractions, right, it went back to displaying everything like we wanted it to. But the thing is, now we have a positive 1 in that pivot position. Not the world's biggest deal, but we've got it if we want it. What are we going to do? We're going to get zeros below. So I want to add 2 times row 2 to row 4. So I want row 4 to be equal to row 4 plus 2 times row 2. Okay, so now I have a pivot of 2, all zeros below it. The second pivot is 1, all zeros below it. If I'd like to, I can multiply through row 3 by a negative, so equals negative row 3. And again, do you have to have positive numbers in your pivot positions? Absolutely not. But for me, it's fairly easy. It doesn't change anything. Again, if negative x equals 3, then x equals negative 3, right? I can just multiply through by negative. It doesn't change the solutions. And if that makes your work easier, then good. How am I going to get a 0 below the second 2, the third pivot, which is also equal to 2? Well, I want to add twice row 3 to row 4. So, row 4 is going to equal the old row 4 plus 2 times the old row 2. And it should have been 3. So I've got the same problem where if I do this, I still am not, well, it kind of worked. It looks like it kind of worked. But since I made the mistake, I'm going to come back up to the beginning, back to the original matrix. I can do run to end. It reevaluates everything in order. And we do in fact have it. Okay, and now we can get done, right? Why? Because we can back substitute. So notice that x sub 4 equals 22, right? If negative x equals negative 22, then x equals 22. So the fourth variable, x sub 4, is equal to 22. But now I know right? What does this equation say? This equation says that 2 times x sub 3 plus, well then I can substitute in, right? If I put the 2 in times the negative 2, I actually have a minus 44, right, is equal to 2. Okay, so what does that mean x sub 3 is equal to? Well, I can divide by 2, so I have x sub 3 minus 22 equals 1. So when I add the 22 to both sides, I get x is equal to 23. X sub 3 is equal to 23. X sub 3. And now I know x sub 4 and x sub 3. So I should be able to plug into the one above, and this is going to be nice because I have 0 x sub 4. So this turns into x sub 2 minus 23 equals minus 13. When I add 23 to both sides, I know that x sub 2 equals 10. Okay, well, if I know that x sub 2 equals 10, I can plug in up here where I know that 2x sub 1 minus 10 minus 23 plus 44 equals minus 3. Wow, so minus 10 and minus 23 is minus 33. Minus 33 plus 44 is positive 11. When I subtract 11 from both sides, I get that x sub 1 is equal to minus 14, I believe. Okay, so that's the process that's called that I talked about, where we do REF first and then we back substitute. Now, it does involve some equation solving, but it's pretty straightforward equation solving. And if you need to, you can use MATLAB like a calculator to help evaluate some of this stuff, and not do it in your head. And remember, we can check our work. How? Let me just say REF little c. Boom. I'm sorry, we want a REF capital C, the original matrix. What the Sam Hill is going on? Oh, it doesn't like this. I'm sorry. Okay. Okay. And you can see, right, that x sub 4 is equal to 22, x sub 3 is equal to 23, x sub 2 is equal to 10, and x sub 1 is equal to negative 7. I must have made an error there when I was solving that equation in my head. But there you go. That is how we row reduce to simplify a matrix, and how we can use the simplified matrices, either in REF form or RREF form, to find the solution set of the linear system. All right, so definitely do some practicing with that. Make sure you know how to do the row operations, and make sure that you know what REF form is and what RREF form is.